have guys doing the lawn outside, so that's what you hear is the lawnmower. But we're going to talk about identifying holes in your graph. And you have holes in your graph when the numerator and the denominator contain a common factor. So there's three different situations that happen with holes. So the first one is your numerator still has a factor after you start canceling everything out. So example would be y equals x minus 3 squared over x minus 3. So obviously there's a common factor in both the numerator and the denominator, but when you expand everything as much as possible and cancel stuff out, that common factor is still left in your numerator. So when this happens, your hole is at the 0. So your hole in this problem is at 3, 0. Second situation is after you expand everything and cancel out what's in numerator and denominator, and no factor is left, that would be a situation like this: y equals x plus 2 times x minus 3 over x minus 3. I cancel out the x minus 3's and I'm left with x plus 2, so I don't have that common factor left any longer. I know I have a hole at 3, comma something, so the way that you figure out where what the y value is you take your x value 3 and you plug it into what's left over. So 3 plus 2 is 5. So your hole is at x comma y, as opposed to x comma 0 when the numerator has a factor. And the third situation is when your denominator still has a factor after you expand and cancel out. So if we had x plus 2 times x minus 3 over x minus 3 squared, and you expand that out, and you cancel that out, you're left with x plus 2 over x minus 3. So that common factor is left in your denominator. This is when you don't actually have a hole there, you have a vertical asymptote. So it's not just a hole, it's a vertical asymptote at x equals. So then you have our first example is graph y equals x minus 1 times x minus 5 over x minus 5. So obviously there's a common factor in both your numerator and your denominator, so they cancel out. So that means we're going to have a hole at 5 comma something. So I'm left with x minus 1. This is situation number 2, where there is not a common factor remaining in either the numerator or the denominator. So what you're going to do is to find the y value of this hole, you're going to plug 5 into x to get your y. So 5 minus 1 is 4. So we're going to have a hole at 5 comma 4. So I have no vertical asymptotes, but I do have a 0 at 1 comma 0, which is right here. And my hole is at 5, 4. And this is just a straight line with a hole in it. Nothing too special. It's literally a straight line. Slope of 1. Y-intercept is -1. It just has a hole at 5 comma 4. If you tried this one, pause your video, write this down on your own paper. Graph y equals x minus 2 times x minus 3 over x minus 3, x minus 4. Pause your video, graph this, try this on your own. Okay, common factor cancels out, so I have a hole at 3 comma something. So I'm left with x minus 2 over x minus 4. So when I go plug 3 in, 3 minus 2 is 1 over 3 minus 4 is negative 1. So that's the same thing as 3 negative 1. I have a vertical asymptote at x equals 4. I have a 0 x-intercept at 2 comma 0. The degree of my numerator is the same as the degree of my denominator, so my horizontal asymptote is at y equals the ratio of the leading coefficients, which is 1/1, which is 1. So, I go graph this. I'm going to start with my vertical asymptote at 4. My horizontal asymptote at 1. Then I have a 0 at 2, 0. So I'm going to, oops, not a hole, a 0. A 0 at 2, 0, and a hole at 3, negative 1. So these are going to connect. So it's going to keep going up towards that horizontal asymptote, and then down towards that vertical asymptote. We're going to look at the order of our vertical asymptote, which is just 1, so it's odd. So they're going to approach the vertical asymptote. On the left side it's going down, so on the right side it's going up. And then I coast along towards my horizontal asymptote.